This is linear algebra 4.21 null space. Previous video we studied vector space, subspace. I'm gonna introduce new space right now, guys. Just to really focus on definition of each section. So make sure you understand the definition we study. Later on, we're gonna find connection relation between all the concepts. Guys, really focus on the definition of what you're gonna study this section. What is null space? Guys, null space is, here is very important definition here, guys. Null space, guys, first, you're gonna have metric m times n. You know that this is number of row, this is number of column, right? Null space definition is you're gonna find all the solution of metric equation a times x equals 0. That's the vector, okay? So we're gonna collect all the x value, make a times x gonna be 0. That's we define the null space, okay? So correct all the x value, which is satisfying. What do you call this one, guys? Remember the previous video or previous chapter here is homogeneous equation because this one is 0. Homogeneous equation. So this one is we correct all the solution for the homogeneous metric equation, we're gonna say null, okay, null space. So let's do the first what is null? What is null space looks like, okay? Let's give the example from next slide. So I give the u, that's the vector, guys. This vector is gonna be, you say 3 entries are 3 vector, guys. This is metric. What is the size of metric? Is 2 times 3. Okay, size 2 times 3. We want to check vector u in the null space of A. So what do you have check? You have check, guys, if this u gonna be solution of metric equation, homogeneous metric equation. A u gonna be 0. That you have check it. This one is u gonna be solution of metric equation. Then you're gonna say, oh, then you're gonna be in the null space. Okay, let's check it. A gonna be, guys, au. We're gonna check au vector. So guys, a gonna be, you see, a gonna be 1, negative 3, negative 2, negative 5, 9, 1. U vector is 5, 3, negative 2. Before we do the multiplication of metric, guys, check it, guys. This is column is 3, is metric A. U vector is 3 entries. That you're going to do multiplication of 2 metric, guys. So let's go this one. Guys, remember that what is going to be multiplication of 2 metrics? 1 times 5, negative 3 times 3, negative 9, negative 2, negative 2 plus 4. Second no, negative 25 plus 27, negative 2. So this one gonna be what? You're gonna see it. This one is 0, this one is 0. Okay? So we're gonna say A times U gonna be 0 vector. Oh, that's gonna be U vector gonna be null of A matrix. That's you're gonna say that, okay? So how can all have the relation between everything we're gonna learn? We're gonna see later on, guys. Make sure understand that. So the vector in the null, which meaning is the vector gonna be satisfying metric equation, okay? What you did the previous slides, we're gonna prove if some vector is in the null space. We define the null space, right? So this slides, we're gonna talking about null space is gonna be subspace Rn, guys. Metric is m times n. Null space gonna be subspace Rn. Guys, remember the definition of subspace? We have checked 3 things right there, guys. We have checked 3 things. So I'm gonna see 0 vector in the null space that you have checked it. null space closed under the vector addition, null space closed under scalar multiplication. That you have to check it, guys. First, 0 is null space, which meaning is, guys, a 0 vector gonna be make 0. That's you're gonna prove it, guys. It's, of course, this one is always 0, but 0 vector times a gonna be 0. So this one is gonna be true. So you're gonna say 0 vector is null space of A. Second is we have proved null space of A closed under the vector addition. So you're gonna pick the two vector from null space. So I'm gonna put the if U vector and V vector pick the null space of A. Then we have proved U plus V still in the null space. That's we have proved it, guys, okay? So U vector V vector is null space, which meaning is AU gonna be 0. AV gonna be 0. Does that make sense? Because U vector V vector is null space. So we have proved A U plus V vector still make 0. So vector U plus V vector is AU vector plus AV vector. Linear, right? So then each one is 0 plus 0 vector. Each one is 0 vector. So that's the 0 vector. What do you mean by that? So you're going to say U vector plus V vector gonna be null of A. Okay? That's you understand that. So this one is giving the null space closed under the vector addition. Everything make sense, this one? Next one is null space closed under the scalar multiplication. So you're gonna pick U is null of A. C is a scalar, any real number. So we have proved something, right? So U gonna be null space, meaning it's gonna be A, U gonna be 0, right? That's in the null space. So let's do this one. A, C, U vector. What happened this one? So matrix transformation is linear. So C gonna be coming up. C, A, U vector. So you find that this one is a 0, right? So this one is C, 0 vector. That's gonna be 0 vector. So you're gonna say C, U gonna be null of A. So we prove this slides null space gonna be subspace of Rn. Okay. All right. Next one is how gonna be expressed null space based on the metric. So this question is we're gonna express the null space based on the metric of A. That's what we're gonna do it, guys. It's a little tricky, but we're gonna do together, guys. So we have find the null space, right? Null space meaning is right here, guys. Here is null space meaning is gonna be null space. A gonna meaning is you're gonna find the vector. Vector is X such that AX gonna be 0. That's you're gonna null space, right? So we have find the solution of this homogeneous equation. How can find the solution for the homogeneous equation, guys? Remember that? Let's do it that way, guys. We have to find the metric, guys, metric, right? So you're gonna solve this one, find the x value. That's you're gonna do it. So you're gonna make argument to the metric. So -6, -3, 6, -1, 1, -7. Here is a 0, 1, -2, 2, 3, -1, 0, 2, -4, 5, 8, -4 and 0, right? Augmented metric right here it is. So we're gonna find the solution. That's you have to do it, guys. Let's quick review, but I'm gonna do comparable operation at the same time, guys. First, pivot, guys, pivot. Here is gonna be, here should be pivot, should be here is 1. So here is a 1. You have interchange two row. So that's first step you have to do. R2 go to R1, R1 go to R2. That's first step. 1, -2, 2, 3, -1, 0, -3, 6, -1, 1, -7, 0. 2, negative 4, 5, 8, negative 4, and 0. Okay? Okay, so let's do the two row operation at the same time. What is next step? You have to take it. This should be 0. This should be 0, right, guys? So what do you have to do? So you have to do 3 times R1 plus R2 go to R2. Negative 2 times R3 plus R1 plus R3 go to R3. So I'm pretty confident everyone is pretty good at order operation right now, guys, okay? So 1, negative 2, 2, 3, negative 1, 0. Here is so second law gonna be 0, 0, 5, 10, negative 10, 0. Third law gonna be 0, 0, 1, 2, negative 2, 0. So next pivot is right here, guys, right here. This should be 1, so you have to take another operation. Divide by 5 times 1 over 5, R2, go to R2. So you're going to see 1, negative 2, 2, 3, negative 1, 0, second note 0, 0, 1, 2, negative 2, 0, 0, 0, 1, 2, negative 2, 0. I think you already noticed here is right there, guys. The second note, third row exactly same. So easily you're gonna make this third row is make 0, right? So negative 1, R2 plus R3 go to R3. You're gonna see this one is 1, negative 2, 2, 3, negative 1, 0, 0, 1, 2, negative 2, 0, 0, 0, 0, 0, 0, 0, 0. This one is consistent system of equation. You can find the infinity solution. But here, guys, you're going to see denominator, third row going to be 0. Look at this one. Here is a pivot. You should make this one, this guy going to be 0. So you have to one more time operation. Make sure, guys, make sure. So you're going to do negative 2 R2 plus R1, go to the R1. So I want to see this one. You guys have to this one. So you see 1, negative 2, 0, negative 1, 3, and 0, 0, 0, 1, 2, negative 2, 0, 0, 0, 0, 0, 0, 0. Okay, now look at this augmented matrix. So you're going to find pivot is right there. Another pivot is right there. So free variable here, x2. Here is x4. Here is x5. So x2, x4, x5 are free variable. So other is gonna be basic variable. So you're gonna find low 1, low 2. You can find the other variable right there. So first one is you're gonna say x1 minus 2x2 minus x4 plus 3x5 equals 0. So you're gonna have x1 is 2x2 plus x4 minus 3x5. That's the first one. Second law gonna be x3 plus 2x4 minus 2x5 equals 0. So you have x3 gonna be negative 2x4 plus 2x5. So you find 3 pre-variable, 2 basic variable. Let's find the metric, guys. Metric gonna be write down x gonna be x1, x2, x3, x4, x5. Right? So x1 you already find it. 2x2 plus x4 minus 3x5. x2 is a pre-variable. x3 is negative 2x4 plus 2x5. x4 is a pre-variable. x5 is pre-variable. How can I write down this one? Everyone have any idea? Pre-variable is gonna be in front of a metric, guys. That's the idea, guys. Pre-variable. So here is idea. x2, I'm gonna use this one. You're gonna guys get the idea here. x2. So find x2 first column. x2 is here, first row. That's gonna be 2. Second is 1. Third doesn't have x2. That's 0. Fourth is doesn't have x2. That's 0. fifth is gonna be 0. That's you write down. Second, next variable x4. Let's find x4. First row is 1. Second is x4. Third is -2. Fourth is 1. Fifth is 0. Everything makes sense? This one more. Here is x5. Here is x5. That's the entry is -3. Second row doesn't have. Third row, they have 2. Fourth row doesn't. Fifth row is 1. That's you find it, guys. So you find the X matrix. Clearly see that, guys. Look at this one. This is, I put the U vector. Here is going to be V vector. Here is W vector. So X is null space. You're going to write down the X is X2 U vector plus X4 V vector plus x5 w vector, linear combination of 3 vectors. So null space of A gonna be span of u vector, v vector, w vector. That you find the spanning set, guys. Okay, so just keep practicing, guys. You're gonna get used to all the operation right there. Let's finish up with this section with practice problem. Okay, they said it's a little extra question right here. So they say this is a subspace of R4. It's not easy question, guys. So H gonna be what? We wanna use, here is a hint, guys. We wanna use null space. So null space is a subspace, they say. So you're gonna show H gonna be, we wanna show, guys, if you show H is null space of some metric. I don't know, the metric. Then we're gonna simply say H gonna be subspace. So we don't have to go through all the 3 steps. That's not an easy equation, guys. So H is null space of some metric. You're gonna show that. Then this one is easily say H is your subspace, okay? Of R4. Okay, how are we gonna do it? That's the big question, guys, okay? Let's go here. Look at this one. So A minus 2B plus 5C minus D equals 0. I'm gonna rewrite this form of equation. That's the first one. Second is rearrange this order. A first, negative A plus C minus B. Okay, rearrange it. Negative B plus C equals 0. You have either way. Some arranging one side 0, 0, left side is this form. Okay, guys? So I want to make this one is augment to the metric, guys. Can you make it? How can I make it? Augment to the metric. Coefficient 1, negative 2, 5, negative 1. Second row, negative 1, negative 1, 0, no, 1, 1, 0. Then you have A, B, C, D. This one is 0, 0. Everyone clearly see that? Oh, what do you say? So you're gonna say this one is A metric. All right, that's the A metric. Oh, this one is X. This is 0 metric. So X is where? X is gonna be H such that, what is X? X gonna be 0. This one gonna be say X gonna be null of A. Oh, so which meaning is H gonna be null set. So H is a subspace of R4. Guys, make sense? We use the theorem. So we find the matrix. So X gonna be null space.